All right, ladies and gentlemen, we have a new reaction. If you want to use this as a journal entry, I know for sure it's section 6.1b. I don't know for sure this is the title, but it's an adequate title. Acid, catalyzed, hydration of alkenes. So that would be your title. That might be the real title. I don't know. Yeah, I nailed one, finally. Now, I want you to know that this reaction starts off identically to the last one. The first step, the pi electrons attacked what molecule? HCl. What category of molecule is HCl? What kind of acid? Strong acid. Alkenes will not react with weak acids. In this universe, I don't know about other universes, but they don't in this universe. Okay? So I want to make the same first step where the alkene pi electrons attack a strong acid. Where does your arrow start? At the pi. And where do they end? I'm listening very carefully. Under the arrow at the H. I like that. That's good. He did not go for pKa 16, which would be a rookie mistake and not valid in this universe. You do not react pKa 16 before -5 ever. It just doesn't happen. That's what -5 means. 10 to the power of 21 more reactive than 10 to the -16. Like, wow. That's like universe is different. I don't know. I got universes on the brain today. Strong acid, 2 carbocations. At the end of the last video, a student was looking ahead and saying, oh, the first product's major and the second one's minor. Made me happy to hear it. After this video, I'm going to tell you it's this stage right here that determined major and minor. One of those cations is a lot easier to make than the other one. But right now in this part, you don't have to describe that. What is the other product each time you made the carbocation? These are called carbocations, by the way. Each time you make those carbocations, what happens to this species? The H went up here on this one, and it went down here on this one. What is the remaining piece of this that I need to draw on the page right now? Yeah, take the H off, put a lone pair on the O, and copy everything you see. And don't forget, that used to be neutral, but it got a lone pair, so it's minus. Anybody remember the name of that ion from Chem 141? No, sulfurous acid is H2SO3. This is a conjugate base of sulfuric acid, or it's the conjugate acid of sulfate. The prefix bi means that. Bicarbonate is the conjugate acid of carbonate. Oh, they didn't tell you that. No, they did not, because they didn't teach you what conjugates were. Ah, I did. That's why I'm doing it. So biphosphate would be PO4 3 negative with an extra proton, so HPO4 2 negative. This is bisulfate. Or you can say hydrogen sulfate. Some of you are probably saying it that way. Names aren't getting points. I'm not writing them down. But this is hydrogen sulfate, aka bisulfate. So is this. Don't use those right now. Do you see sulfur in the products? No. Please don't connect these to this because they're not connected in the product. There are clues if you use them. Where do you think the O here comes from if it doesn't come from bisulfate? There's a whole molecule we haven't even talked about yet. Water. Yeah. Water's going to take the place of Cl negative in this mechanism, but you're going to do it exactly the same. You need a lone pair Does water have lone pairs? Yeah. Yeah. So draw me a water. Put a lone pair on it. You do know there's 2 lone pairs on that O, right? I only need 1. Do another one right here. Put a reaction arrow where they react with each other. Lone pair goes to where? Where'd the lone pair go on this one? To the carbon that had the plus charge. You can say it that way. To the carbon that has the plus charge. Don't go to the plus charge. No, no, no. Arrow from lone pair to the carbon that has a plus charge. To the carbon that has a plus charge. Notice you did not touch the H's on water. Did you? Didn't do a thing with them. So how many H's will be on the O when you're done? 2 still. What kind of O has 3 bonds and a plus charge? Because that's what you're about to have. We got a name for this O. It's in a family. It's in a family. Here's the name of the family. You don't get points for it. I'm going to erase it. Then I'm going to erase its pKa. These are just reminders. Those are reminders you're supposed to know. Maybe you didn't know it's called an oxonium. Hydronium's in the family too. That's H3O plus. O with a plus charge is an oxonium. Just like ammonium is nitrogen with a plus charge. The same logic. So I don't need oxonium pKa3, but that's a nice hint. Oh, it's okay. Redraw. And same story here, except the oxonium's in a different spot. Oxonium, pKa -3. We're about to finish. Each product needs 2 arrows. Talk to me. How does that become that? And how does this become that? What has to happen? Just look at them and tell me what has to happen. You don't have to know anything to answer this question except be able to tell me what atoms we're talking about. I have to lose a hydrogen. Bisulfate is going to take it. That was good. The bisulfate. Tell me what bisulfate becomes when you do this. Sulfuric acid, it regenerates the catalyst. Seeing words that are in the textbook makes me, or hearing words that are in the textbook makes me happy. There you go. I didn't draw very well. Sulfuric acid, you don't need these words. I'm going to erase them very soon. Catalyst is regenerated. Don't need those words for a mechanism. They are truth. Regenerated. You started with sulfuric acid. You ended with sulfuric acid. Catalysts are not used up. That's half the definition. The other half is they speed up the reaction. Well, without sulfuric acid, there's no reaction. So how's that for speeding up the reaction? Okay. And the catalyst does not get used up. So I don't need those words. They're going away. I do need the H. I don't need it there either. You can get rid of it. I don't need to see it. It's not, I didn't get rid of it. I mean, you don't need to show it to me. But everything I said was true. You just made sulfuric acid. You saw it, right? This lone pair picked up a proton from there. It's now sulfuric acid. Same story here. I love it when you get points for doing the same thing twice in a row. Don't even think about wording that the other way. You're losing points for not doing it twice in a row. Let's not even go there. Getting points twice. So this one you can tell there's a lot of labels, right? This would be a great label question. And everything he needs here. This wasn't wrong, we just didn't need it. Got the title for the section. And you do know this is a nice way to make alcohols, right? Tertiary alcohol over here, secondary alcohol over here. And that's that. What I'm going to do is stop this video, and then we're going to do a little exercise underneath it before I pick it up from you.